Hi, now we're going to discuss access and visibility of both variables and methods to classes, to objects, and subclasses. So sometimes we want to use variables within the class, or we want those variables not to be seen by other classes. The reason you might want to do this is you may have a variable that is specifically designed to perform functions within the class or within methods of the class. And there may be methods that are called within the class that are only meant to be called through a method within the class, but not from outside the class. So there are really four ways we can do this, and there are three keywords that we're going to focus on. The fourth one we're not even going to worry about. And that is public, which basically means that a method or a variable that's designed as public is visible outside the class. So whereas we were in our main function and the R for rectangle could call getWidth, we would make that public and it would be seen outside of the rectangle class. If we had declared the methods private or the variables private, it can only be seen by methods by methods within the class itself, so within, say, rectangle. And protected means that the variables act as private, but unlike private, those methods and variables can be subclassed. So another class that extends, say, rectangle, would see the other methods and variables that are listed as protected, but they would act as private to anything outside of the class and the subclass. So let's take an example of this. We have our geometry class. We have our object R, which is created as a new rectangle. We see that we have a variable length and a method set width. If we look at the rectangle class, we notice that the two variables length and width are declared as public. So length can be seen outside of the rectangle class and used. In the case of the set width function, that is also defined as public, and it can be seen outside of the class. Again, since width is within the class, we should have no problem seeing it inside of any method within the rectangle class. Okay, so now we see that we have private access, which restricts the visibility of methods and variables. So going back to our previous example of geometry class, we have our rectangle R equals new rectangle, r.length equals 10, and r.setWidth 5. Length actually is declared as private in rectangle. So this line will actually result in a compile error because the length is private. Width would also be private. In the case of set width, since set width is public, it can be seen outside of the rectangle class here. But since this is private, it also cannot be subclassed. So when we try and do class square extends rectangle, square being the subclass of rectangle, we notice that this function set side is trying to use length and width. And this will also return an error because it'll say length and width have not been defined. And as such, it cannot be defined because the programmer thought that rectangle would have the length and width, but because it's private, it is not extended into square. So it's good practice to prevent direct access to variables where at all possible. You want to always start with variables that are private, and we would like to create accessor methods. So we make our variables private, length and width, and then what we do is we'll create public methods, say set width and set length. And this is just a nomenclature or a best practice, where we can then pass in a variable x, okay, and put it into width and length. We would also have a corresponding get width and get length, which would return the type of the variable itself. Length and width are integers, so therefore these methods must declare the return value as an integer. Notice all of these methods are public. The reason we do this is because within the code, we could actually guarantee certain functionality. For example, if we wanted to ensure that the width and length were always greater than 0, we might put an if clause in here that would return an error if the developer, or if it was done via input, actually did put a value that was less than 0. Now, protected access is basically similar to private in the sense that it does restrict visibility of methods and variables in the same way. Here we have our same example of length and set width, but now we've got protected int length and width. So what happens is that length is still going to result in the compile error on this line here in geometry. However, now that we do square extends rectangle, we'll find that length and width are inherited and therefore are now visible to square in the same manner that it would have been visible to rectangle. However, if square was defined out here, and we tried to access square.length, or s.length in that case, it would also return a compile error because outside of the square class, those variables could not be seen. So before we said it was good practice to prevent direct access to variables since we want to ensure the integrity of the information within the class, and everything therefore should be private. However, we're going to slightly modify that because we want to make all the variables private unless there's a reason to allow the variable to be inherited. So in the case of square, it might be obvious that we would need the length and the width, and so therefore we might convert this from private to protected, and still do the same where we allow the public methods to be visible for access to those variables.